focus actually over the next 4 sessions, focus on total error-proof prevention and different options that Balluff have. So to get started, we're going to discuss about a few terms and conditions that are commonly used in error-proofing environments. And so error-proofing, if we look at that definition specifically, error-proofing refers to the implementation of fail-safe mechanisms to prevent a process from producing defects. And this is either an automatic device or a method that makes it impossible for a fault to occur or make the error immediately obvious once it has occurred. Poka-yoke is a Japanese term, a derivative from poka, which means inadvertent errors, and the term yokuro, which is to avoid. So that word is actually defining a process of error proofing. And finally, kaizen, which is also a Japanese term that we hear commonly in error proofing environments. Kai means to change or modify, and zen is to improve or make better. So kaizen is the process of continuous improvement. So what is the objective of error proofing? It's to seek zero defects and elimination of quality control using manual inspection. It's to reduce operating costs. And in reducing operating costs, that would include costs such as rework, scrap, warranty, secondary inspection, overtime costs, and special shipping. So let's look at some of the primary sources of error. The first primary source of error is through poor standards or procedures by the customer. It could be as a result of a machine failure. There may be materials that do not conform to the standards of manufacture, which would fail. There may be worn tooling that could produce ongoing failed products. There may be human error that causes the fault to occur. So essentially, all of those faults that are listed above can be resolved easily with a plan of action for error proofing, of course with the exception of a human error. So sources of human error include forgetfulness. If there are unskilled or lack of experienced individuals at the workstations, errors can certainly occur. Employees that are lazy, not paying attention to the standards of manufacture. If people are in too much of a rush, that source of pressure and anxiety can cause errors to occur. And then there's always those that have malicious intent that intentionally cause errors to occur in the manufacturing process. There may be misunderstanding of what the proper manufacturing sequence or process should be at a particular workstation. People may not be paying attention to what their job tasks happen to be. There may be no standards or no defined order of process to be done. And people, of course, trying to make their job easier, taking shortcuts, which can introduce probability of error. Here we see an example of that from the Noah's Ark shipbuilding company. So next we'll have a short YouTube video that kind of covers what poka-yoke or error proofing actually is. So the importance of this is although they showed the example of the video for an automotive application, this process of error prevention is absolutely applicable to any vertical market. So we can apply that to not just the automotive, but the food and beverage industry, the packaging industry, cosmetic industry, pharmaceutical, and so on. So why do we care about error proofing? And it's simple. It's because our customers do. And here we see an example of a truck that's carrying materials to crusher from a mine, and although the catastrophe is with the vehicle, it's actually affecting the entire manufacturing process of that particular mine. So now their productivity is suffering because a key asset within that facility is now rendered useless. So how do our customers affect, or sorry, how does air proofing affect our customers? Air proofing is not a one-time event. This is an ongoing process that's adopted by all manufacturing. This is something that our customers are continually looking to do and to improve. Show itself in the first statement. Air proofing is a way of life. It becomes adopted as a process of the manufacturing facility itself. They also need architecture to support this air proofing strategy, and this is where Balluff really becomes a key asset to our customers. We're able to provide the components that are part of an air proofing solution and bring that information right on to the control architecture that our customers are using to control their manufacturing process. They're able to get information as to what the failure is and where the failure is located at. So why would our customers consider Balluff? As mentioned just earlier in the last slide, Balluff is a uniquely qualified supplier, as we're able to provide total air prevention solutions. There's no other company that can provide a combination of sensors, vision, traceability, and other systems together with a flexible, expandable IO link-based control architecture. So this is really a unique value proposition that Balluff have. So what is air proofing? It's looking at quality, it's establishing proper sequencing, having just in time the right products in the right place at the right time, and it's being able to trace those products within their facility. Air proofing, we've coined the term as total quality management. So we want to identify the trouble spots. That would be our customer's responsibility. We want to identify the correct detection method, and that's where we can provide value to our customer. Then we want to come up with strategies to contain the problems or discrepancies, and that's something that both our customers and Balluff, and repeat that process. So here's our total quality management strategy. So identifying trouble spots. The first step is to look at all manual operations, and where there are repetitive tasks, that's a problematic error that faults can commonly occur. That's where parts are often installed. There's a sequencing process involved. There may be color recognition involved, and data entry, manual data entry involved. Those are all areas in which errors can occur with a high probability. So let's look at a few areas where common trouble spots can occur. Here we have two screws mounted in place. The first is missing a washer, so it's missing a wrong part. The next example is where we're having an incomplete thread on a workpiece. Next is an example where we're also missing another part. The underlying washer is missing. So the sequence of the washer is incorrect. And here is an application for color mark. And finally, here is the difference between an automated and manual way of entering data. In this case, we are trying to load a recipe. All three of these parts look identical, but there is a different recipe for each particular tool. So using an RFID or a barcode type of method, it would be a way for automatically loading the right recipe into the machine. Here's a sequencing application. If this manufacturing sequence is incorrect, then the part would be deemed defective. And here's a simplistic mislabeled product using barcode. So for machine setup, we can You utilize RFID to assist in correct and quick changeover. We can eliminate the probability of the wrong tooling being installed to manufacture the wrong part, and the images below show some examples of just that using RFID. So we talked a little bit earlier about evaluating all manual operations. When there is a pure manual operations, typically you would have two checks or manual checks per operation. So that still has a high probability of error, but certainly your operating costs have increased because you have those 2 checks in place. With manual operations, typically there's 1 error per 300 keystrokes. So that's certainly an area that customers would look to reduce or eliminate. And for those applications for doing color recognition, if that's done manually, it's been found that customers become desensitized in less than 2 hours, and that could also increase the probability of error from repeating itself. So here we have some examples where problems have occurred, and the customers, in this case, what they have done is they've bypassed sensors. As soon as you bypass sensors, then the customer has increased the probability for having failures occur with the product. So we want to make sure that process is being done correctly by having the correct sensor put in place for the correct application. So that concludes today's session on air proofing, and